Welcome to Circuit 1C. In this situation, we are now using a photoresistor instead of our potentiometer. Notice we have our LED setup and we have our 3 wires for our potentiometer. But in this situation, we have a photoresistor with a 10 kilo ohm resistor. Removing our setup from Circuit 1B. My board is already disconnected. Hopefully yours is too. Alright, so we don't need this. This photoresistor is right on pin 25B and the other leg is on 26A. The leg positioning doesn't matter since this is a non-polar device, our 10 kilo ohm resistor. Going to pin 26C and then I bend it a little bit and then the other one goes to 27D. And now I need to move all of these jumper wires down a row. So 27E, blue is to 26E, and red is going to 25E. So for the entirety of this circuit, you have to have your serial monitor turned on so you can actually see the value that you're reading. We see a few things. We have our 883 value on our serial monitor. Our LED is also turned off. And we also have our LED on our RX right on our red board is blinking really fast because this is saying that it's communicating very quickly with our computer and it's just sending back information. You know your circuit is set up right when you cover your photoresistor and your LED turns on. Notice this is very quick, it's a quick response. Lines 1 through 12 are pretty much just a comment. Shout out to Codebender again. In line 14 and 50, we have identified 2 integers in this case, so these are just placeholders. Photoresistor starts off at 0 every time, and our threshold is at a value of 750. We'll go back to this later. In void setup, we identify that we are going to be using our serial monitor and we're communicating at 9600. In line 21, we have our LED identified as an output, so we're sending electricity to our LED. In void loop, we are running this code over and over again. In line 27, we're saying that our photoresistor, once again, is just a term, is equal to the value that is measured in analog read 0. So pin 0 is right here. And then serial LN is printing out any value that is associated with photoresistor, which is also related to analog read A0. So here's where the magic is happening in line 31. So line 31, we have this if statement. So if our photoresistor is less than the threshold, so let's look at our serial monitor again. So notice if our photoresistor is less than threshold, threshold is just a term that is associated with this number up here, 750. So if our photoresistor is less than 750, digital write 13 high, so we turn on our LED. So once again, if it's less than the threshold, so let's see our measurement. We're above 750, now we're going below. And our light turns on. So notice if I cover my photoresistor a bit more, my LED stays on. Our else statement, so in any other value that is above threshold, we are going to turn off our LED and we're going to stop sending electricity to pin 13. Our value is above 750, so our LED does not turn on. And this delay right here is saying that we're running this code over and over again every 10th of a second. So we can also do this every 4 seconds if we type in a delay of 4000. We can do it up to 10 seconds. It's up to you. In one situation, let's say your light never turns on, it could be an error with your photoresistor. So what you want to do is change your threshold value to be consistent with the lighting in your room. Maybe you're not producing enough light, so you might want to lower this value down to 600, 400, adjust it accordingly, and see what happens. And in the other situation, just make sure your USB is connected and you have selected the right port. Just a little reminder. We're just creating a response pattern with our LED whenever it turns on. So we're going to make the LED blink whenever our photoresistor reads a value lower than the threshold. In this situation, we want to just add a few digital write highs and lows with some delays. Let's go ahead and copy line 34. We don't really care about this comment, but let's just add it. And now we're going to add a delay. So we can go enter, type delay, parentheses, semicolon, but we need to add a value. So I'm going to add a value of 500. And I'm going to add another delay in line 35. And let's verify our code. So click verify. You can do this on Codebender as well. And my code looks good. So now let's go ahead and upload. So in this situation, my LED is now blinking a pattern because I'm covering my LED. And that's pretty much it. So make sure you turn on your serial monitor while using this. So for challenge number 2, we are just replacing the 10 kilo ohm resistor with another LED, and we're just observing the changes to see what happens. So let's make sure we disconnect our board really quickly so that we don't damage it, and let's get an LED. Alright, so I used a red LED to be consistent, and notice we're going to see the changes in the brightness as we cover our resistor. So this LED is receiving a lower voltage as we cover the photoresistor. And that's pretty much it. So try it out, add more LEDs if you want, and see what happens, or use different colors.